Welcome back, everyone. This is Module 6A, and I think medyo mabilis lang to kasi extension lang naman siya ng ating previous module, Module 5A, which discusses yung ating one-dimensional arrays. Okay, ngayon, two-dimensional or multidimensional arrays lang, and yung application niya lang sa functions. So, madali lang to kasi we have the basic knowledge na sa 1D arrays. Okay, let's start. When we say two-dimensional arrays, instead of a list form ang meron sa atin, kasi kapag list form, di ba, kayang-kaya natin gamitin sa one-dimensional array. Kapag 2D array, meron tayong data, typically, kapag gumagamit ng 2D arrays, in table form. Meron tayong number of rows and number of columns. So, 2D array siya kasi may two components tayo, the x and the y, the horizontal and the vertical. The number of rows yung horizontal, number of columns yung vertical. And kapag ganun, if we apply this sa math, these are used, or yung 2D arrays natin are typically used kapag nag-handle ng ating mga matrices. Okay, di ba? May mga matrices na tayo sa ating computational part. So, expect natin na may matrix tayo sa Module 6B. Okay, so kapag 2D array, pag sinabi 2D array, meron tayong a fixed collection of, may collection tayo of a fixed number of components arranged as the number of rows and columns. So, meron tayong two dimensions or two indices na. Okay, so instead na list lang sa isang bracket lang, we expect na dalawa na yung dimension ng ating 2D array. And paano siya dinideclare? Ganito lang. Same lang sa ating 1D array. Meron tayong data type. Okay, kung ano yung type ng ating laman ng ating array. So, dapat iisa lang lahat yan. Same type lang dapat lahat. Hindi pwedeng may isang nakasingit na double or ipa-iba-iba yung ating data type. So, dapat isa-isa, for one array, for one 2D array, kailangan isang data type lang yung hinahandle niyang values. Okay, a certain array name, and then expressions for each dimension. So, first dimension is the number of columns. Second dimension, first dimension number of rows. Second dimension number of columns. So, itong dalawang to dapat this always expressed in or evaluates into a positive integer kasi wala namang negative number of rows or wala namang zero number of rows and columns. Okay, so dapat basta any, pwedeng constant, pwedeng variable, or any expression, dapat pag na-evaluate siya, positive integer. Okay, so when we declare, for example, a sales array, a 2D array na sales yung name, tapos double yung nakastore sa kanya, tapos ito yung pagkaka-declare. May 10 na rows and 5 na columns. So 1, 2, we start with 0 sa indices. Okay? So just like sa 1D array, we start with 0 kapag nag-index tayo. So kapag 10 yung number of rows, ang indices natin range from 0 to 9. On the other hand, ang column natin, ang indices niya start from 0 until 4 kasi 5 lang yung number of columns. Okay, so how do we access each element or a certain element ng ating array? Same lang sa 1D array, di ba? I-specify lang natin sa loob ng bracket yung index natin. Okay, we just use or call the array name, and then we write two brackets. Sa first is yung index ng ating row, sa second is yung index ng ating column. Okay, again, itong mga indices na to should be 0 or positive integer. And just watch out sa ating index out of bounds na error. For example, gusto mo or nasulat, for example, meron kang array, 2D array na 9 by 5 yung components, 9 rows, 5 columns, pero nung gusto mo kunyari yung nasa 9th row, nilagay mong index is 9 instead of 8, magkaka-index tayo na out of bound na error. Okay? So just be careful with that. Let's take this one as an example. Nag-store siya ng value na 25.75 kay sales, 5.3. And ibig sabihin, yung 5 is for the 6th row. 1, 2, 3, 4, 5, 6th row. Tama? And then, for the 4th column. 1, 2, 3, 4. So, dito. So, store niya dito sa element na to si 25.75. Okay? Di ba? Madali lang naman intindihan. Straight to the point. Now, paano tayo nag-initialize? So, declaration, ganun lang, kasimple. Paano naman tayo nag-initialize? Just like what we do sa ating 1D arrays, we list down, di ba, lahat ng elements and then separate by columns. Pero paano to? May rows and may rows tayo, may columns tayo. We just separate yung bawat row natin using braces. So, ganito yung example. If you want to completely initialize yung laman ng ating, let's say, board, yung name ng ating 2D array with 4 columns and 4 rows and 3 columns, we just write each element ng bawat row, okay, and then enclose them sa braces. Okay, so bawat laman ng bawat row, hinihiwalay lang natin ng braces and commas. Pero yung loob ng, yung elements ng loob ng, or sa isang row, separated by commas lang. Okay, so isang row, first row to, second row, third row, di ba? Madali lang, fourth row. We expect na may apat na rows with 3 elements each or 3 columns each. Kaya ganito itsura na. Okay, so 2, 3, 1, ito yun. 15, 25, 13 ito. 20, 44, 7 ito. 11, 18, 14 ito. Okay, so ganyan ang mag-initialize during declaration ng ating 2D array completely, ha. So meron din tayong partial as I'll show here. So int array 1, 2 by 3. So meron tayong 2 rows and 3 columns. Ito complete pa to, di ba? Complete initialization 1, 2, 3, 4, 5, 6. Tama. Okay. Now, if we want to partially initialize, ganito na itsura na. Let's say array 2, ganun pa rin, 2 rows, 3 columns, pero ganito, di ba? Wala na tayong nakikitang braces or separation ng bawat row. Bakit? Kasi aware naman yung program natin, or si C, na meron lang 2 rows with 3 elements or 3 components each. So, kapag nakakita na siya ng 3 components, automatically alam niya na tapos na yung nakastore sa isang row. So, yung succeeding values, isa-store niya na kay next row. So, 1, 2, 3, 4, 5. So, ito, isa-store niya dito yung first 3 terms and yung last 2 dito. Okay? Pero may natitira pang isa. Just like what's happening kapag 1D array, this automatically initializes to 0. Okay, so yung mga hindi nasa state sa initialization, automatically initialize to 0 kapag nilagay na siya sa array. Okay? So, pwede yun. Isa pang variation yan is ganito. Diba, we expect dapat na 3 yung number of elements per row, pero as you can see dito, separated by braces. So, we are sure na this one is for the first row and this one is for the second row. Since dalawa lang yung naka-initialize or may value, initial value sa ating first row, yan ang nalagay niya. And yung hindi niya in-specify na value, automatically initializes to 0. So, 1, 2, 0 yung first row. Yung second row, 4 lang yung start. Okay, yung hindi niya minention na dalawa, automatic 0 na yan. So, 1, 2, 0 and 4, 0, 0 respectively. So, diba? Medyo simple lang. Sige, let's move sa next part. That would be processing. Just like what we're doing sa 1D array, we can also apply that sa 2D arrays. So, pwede tayo mag-process ng single element, meaning may kukunin kang single value sa ating array, yun, so store sa isang variable, di ba? Single element lang yung gusto natin doon. Siyempre, you can also, pwede rin natin pakialaman yung buong array. Including examples niya is, if you want to initialize yung laman ng ating array, siyempre, i-modify natin yung entire array. Or if you want to print yung lahat ng laman ng array natin, siyempre, we need to read lahat ng elements ng ating array. So another would be row specific lang. If you want to process a single row, if you want to get the largest element, smallest element, or get the sum of all the numbers in a row processing yon. Siyempre, may column processing din tayo. Same lang sa row, pero ang focus would be per column na. Tama? Let's show an example showing all these. So let's say you have declared a matrix, okay, an array with matrix as name. Number of rows is 7, number of column is 6. So you can see here yung indices ng ating rows range from 0 to 6 and for our column range from 0 to 5. Okay? Nag-state lang siya or nag-declare lang siya ng integer variables ij, sum, and largest for the processing. So pagkuha ng sums and mga largest values. Okay? So ito yung papakialaman natin matrix. sa succeeding slides. Okay? So, first processing would be initializing yung entire array natin to 0. Di ba sa 1D array, isang loop lang? Isang I lang? Kasi isa lang naman yung component natin. I mean, isa lang yung dimension. Pag two-dimensional, dalawa na yung loops natin. Bakit? So we have variable or loop control variable for the number, for the rows. Okay, and separately, meron din tayong index, okay, or control variable for the number of columns. Okay, yung inner, yung outer rather, yung outer na for loop, uh, specific lang for traversing each row. Okay? So if you wanna move to the other row, next value lang ng I. Pero yung inner natin, yung inner for loop natin si j, which is yung index ng ating column. So ibig sabihin, for example, sa I equals 0, di ba yun yung outer, magta-traverse lang siya per column muna dun sa inner. So matrix 0, 0 is i-assign niya as 0, and then matrix 0, 1, which is yung second element, magiging 0 din, and so on and so forth hanggang umabot siya sa last column, which is yung 0, 6. Sorry, 0, 5 rather. Matrix 0, 5 equals 0. Okay? Pag natapos niya na yun, ibig sabihin tapos na tong inner for loop, gagawin niya na tong outer for loop. So, mag-move na siya sa next row kasi I equals 1 na. And then just repeat assigning the value of 0 sa bawat element ng ating row. Okay? So, after yan, pag natapos na lahat ng I values, na-initialize na lahat ng values ng ating, lahat ng elements natin to 0. Okay? How do we print naman? Same lang naman yung for loops natin, dalawa. Okay, and then, as you can see here, pinrint niya lang yung bawat laman ng matrix ij natin. Okay, so per element. Okay, so for loop for the row, for the column. Okay, ang format lang yan is may 5 field widths tayo for each element. And then may space. Separation lang ng bawat element natin. Okay, and then kapag natapos niya yung for loop ng isang row, di ba pag natapos niya lahat ng column sa isang row, to-print niya na new line character para mag-jump siya sa next row natin. Okay, next value ni I. Right? So, that's how we print yung isang buong array natin. And how do we read naman yung data natin into array? So, gusto naman natin dito is may user function tayo and then yung kung anong arrangement ng pagkaka-scan niya from our user input, isa-store niya lang lahat ng bawat element na yun sa ating array. Ganun lang din. We have for loops for the row, traversing ng row, traversing ng column, key, and then bawat user input, isa-store niya lang kay matrix ij. Okay? So, ang pag-assign niyan is from left to right ng bawat row. So, row 1 to 0, 1, 2. Pag ano. Hanggang maubos niya lahat. Tititigil lang siya yung pag-scan kapag na-complete niya lahat ng elements ng ating matrix or array. Right? How do we sum? Similar lang sa mga ginagawa natin. Okay? Meron tayong for loop dito sa row. Tapos, naglagay lang siya dito ng initialization ng sum to 0. Okay, bago dun sa second for loop ha, kasi kapag nilagay mo yung sum dito sa loob ng for loop, bawat iteration ng j, magbabalik siya sa sum equals 0. Hindi natin gusto yan. Basta gusto lang natin is yung initial value ng sum is 0 para yung bawat or yung succeeding na nakastore sa bawat element ng matrix, mag-add up lang kay sum. Okay? So kapag natapos na na-traverse na lahat ng elements ng column natin per row, yun na yung nakastore kay sum. And isa-store niya na, i-print niya na dito, sum of row blank is blank. Okay? Tama naman. Okay, so kapag tapos niya na isang row, babalik niya ulit yung sum equals 0 para kunin niya naman yung sum ng succeeding rows. Alright? So, summing by column, same lang din. Diba? Parehang-pareho lang yan. Ang nakaiba lang, unahin na natin yung j instead of, kasi yung column naman yung ating, per column naman yung tinitignan natin. So, tatraverse na natin per row initially. For example, for j equals 0, or for column 1, move lang tayo per row. I-add lang natin ng i-add yun sa value or phi sum. And then, piprint niya. Sum of column blank is blank. Okay. May plus 1 yan, just like yung I plus 1 kanina. Kasi nga, for example, row 0, that means, ano yun, di ba? Row 1 talaga in real life. So, kailangan may I plus 1 or J plus 1 rather. Alright? That's how we sum yung bawat element ng column natin. And for the largest element in each row, same lang naman. Okay, instead of a sum variable, meron naman tayo dito largest variable in which we initially put yung value ng first element ng ating row. Okay, inassign yung matrix I0 or yung kapag first row, first element na i-assign niya kay largest. Okay, so that's our first guess. Okay, as you can see dito kay J, nag-start na siya kay 1 kasi nga alam na natin yung value ng first, diba? Yung mga succeeding na to na columns. Okay, yung succeeding columns, i-compare niya dun sa nakastore kay largest, which sa first part is yung first element, diba? Kung ano mas malaki, sa-store niya ulit kay largest. Okay, and then, balik lang siya dito. Okay, i-compare niya lang yung largest dun sa succeeding pa na elements ng uh, matrix or ng array natin for that row. Okay, pag okay na, yung largest element in that row is kung ano man. Okay? So, those are some examples. Marami pa naman examples ng processing ng 2D arrays natin, pero those are just the basics. Okay, I hope you understood that. Okay, so let's just move sa isang short discussion lang on multidimensional arrays. Well, multidimensional array kasama na yung 2D dun kasi more than one na yun. Pero if you want to have more than two na dimensions, di ba? Pero I think limited lang naman yung applications nun. So, I hope hindi natin magamit sa CE25. But basically, pag sinabing n-dimensional arrays, meron tayong fixed number of components arranged in n dimensions. Hindi lang row by column. Meron pa tayong, for example, x by y by z. Diba? 3D. Pag 4D, hindi ko ba maisip. May time pa, ganyan. Okay, so I hope hindi na siya gamitin. But basically, ang syntax niyan, similar lang naman sa arrays, sa 1D arrays and 2D arrays. Just you still have a data type. So, same type pa rin dapat lahat ng laman ng ating n-dimensional array. Yes, you assign a certain name, array name. Okay, and then, yung number of brackets natin, syempre n. Kasi may nga tayong n dimensions eh. So, may n tayo na number of brackets and each of that bracket should contain an integer expression value or constant. So, dapat positive integer yan. Okay. So, yun lang. That actually ends our introduction to two and multidimensional arrays. Sa ating next content, I will be discussing the relation or how do we use 2D arrays as parameters ng functions. So, for now, thank you and goodbye.